Now let us discuss about the uses of dimensional, that where it is used. So dimensional analysis means dimension of a physical quantity can be used as a principle of homogeneity or as the conversion factor. So first of all we will discuss what is principle of homogeneity. Homogeneity means homogeneous, like homogeneous mixture means uniform. Homogeneity means uniform, same. So, principle of homogeneity means that two or more quantities in addition or subtraction should have same dimension. Let us suppose we are going to add 5 meter. So, it must be added with meter, not kg, like this 5 meter plus 2 kg. This is not possible. We may only add quantities having same dimension, means having same unit. Next, quantities on either side, quantities on either side of expression or equation should have the same dimension, should have the same dimension. Quantities on either side of expression, let us suppose we are writing an equation v is equals to u plus at, v is equals to u plus at. So the unit of this quantity present on left hand side should be equal to units of the quantities present on right hand side. Let us suppose what is the unit of this final velocity. So it will be meter per second. Now the unit of this initial velocity, it will also be meter per second. Now what is this unit? So meter per second square acceleration into second time. So second and second gone, meter per second. So the unit should always be same. If unit is same, then we may call as that the quantities are following principle of homogeneity. Next, using this principle we can check the correctness of a physical quantity. Whether the given quantity is correct or not, we may find with the help of these particular principle, that is principle of homogeneity. Let us suppose someone has asked us that s is equals to ut plus half at square. Whether this equation is correct or not, we may find it with the help of principle of homogeneity. So how do we find whether it is dimensionally correct or not? So just find the dimension of quantities present on left hand side, then find dimension of quantities present on right hand side. If they are equal, then we may conclude that the given quantity is dimensionally correct. So let us see one example. Example is v is equals to u plus at. V is equals to u plus at. Now let us see whether it is dimensionally correct or not. So we have in LHS v. So dimension of v is m0 l1 t minus 1. Why? Because velocity, v for velocity, whose unit is meter per second. For meter we are using L, for time second we are using time. So L1 t minus 1. Now on RHS u plus at, u is also an initial velocity, so its dimension will be same, m0 l1 t minus 1, plus acceleration. Acceleration means meter per second square, means lt minus 2. So m0 l1 t minus 2 into m0 l0 t1. Now here t minus 2 and t plus 1, so it will cancel and become t minus 1 l1 m0 and then m0 l1 t minus 1. So this RHS, dimension of RHS, is equal to dimension of LHS. Since they are equal, hence the given physical quantity is dimensionally correct. So in this way we may find that whether the given quantities are dimensionally correct or not. So this is all about principle of homogeneity. In next lecture we will discuss about conversion factor. Now you should practice more and more question. For that you may join our Telegram group. So thanks all for the day.